Right. Yeah. Quickly, just for the recording. Functions. And functions and structs today. Functions first. We do functions to compartmentalize because that can tell us like what each section of code is doing. Also, another important use of a function is to prevent duplicate code. So like if you're gonna find the maximum of two numbers, like maybe 1,000 times, you don't want to like keep making 1,000 comparisons. But actually, before we do that, how about we start with a little exercise? I believe my brother has gone over conditionals, right? Like if and whatnot. Is this true or no? Yesterday. Okay, yeah, that's what I thought. Okay. So just as a beginning exercise, I'd like everyone to spend maybe like 2, 3 minutes writing some code such that you have two numbers A and B, and then output the larger value. So yeah, everyone just try that for a second, right? Like C++ code for this. Meanwhile, I will try to do Replit. If anyone has the answer, please feel free to like send it in the chat or something. Don't worry about functions right now. Just write some code that would like okay. I don't have iOS on YouTube. Does anyone have any ideas? Hmm, maybe I'll start calling. Nini, do you have any ideas?
I have half formatted like the first part, but I haven't formatted the other
Okay.
second half
Um,
yet.
all right. Sounds good.
Um,
Just send it to me. Don't worry about the formatting for now.
okay.
Okay. Yeah, this looks basically right. Let me just translate this into code. I have another submission as well. Okay. If someone saying something or no? Okay, Elaine, you're kind of cheating, but I'll get to that in a bit. Okay. Wait, how do you like? Well, how do you use this? I don't know how to use autocomplete. I'm not gonna bother. Okay, I guess if we're being pedantic, we should also add the case where they're both equal. No, you don't. I guess you don't need to change it. I mean, if you get the point of how to do it, then that's fine. Okay. So great. This is our code for like just printing up the larger value of two numbers. And so, okay, let's kind of shove this aside for a second and go back to functions. We will come back to this later. Okay. So what does a function do? You have some code that's associated with a keyword, which is also known, is that really right? Okay, keyword technically has another meaning, but basically there are four parts to any function. First is the function name. Um, this will make sense when we do an actual example, which I will get to very shortly. Um, it will input some amount of variables, which we call parameters. It is actually possible also to not have any parameters at all. And finally, you will return a variable, which means that like you will be able to get some value that the function will communicate to whoever's calling it. And there's a special keyword known as void that can prevent you from returning a variable when you don't want to, which is also kind of complicated. So we'll get to that a bit later. And then finally is the function body, where hopefully it does something meaningful. If it doesn't, then it's kind of a useless function. You should have written anyways. But yeah, okay. Before we go on to the next slide, what is the next slide? Oh yeah, the next slide is just why use a function again. Yeah. Reduce redundancy and yeah, reduce redundancy, also compartmentalization, so it looks better. Let's go back to here. And actually, we already, I know, and we haven't really gotten into how to like define functions. You know now what the parts of a function are, but we haven't really told you how to code it. But there already is a function within this code. Can anybody spot where it is? Main function, that is correct. Why is this a function? Okay, I'll tell you why that is a function because I don't think you know this yet. But once you put these parentheses behind it, this will indicate that you're taking in some amount of parameters. So actually, there is, so because there's no parameters here, this is empty. That means main will not have any parameters. Um, so yeah, this is the function name. Um, okay. Now, what is the return type of this function? It's kind of obvious. So another return type of main. Yes, it's just an int. Uh, the main function actually has some pretty funky properties that I might probably talk about later. But yeah, I guess to be safe, let's just add the return 0 for good measure. 0 in CS, if like a function, if you run an entire program and return 0, that means that the program executed successfully. So yeah, if you do return 1, return -1, return random stuff, the throw something on fire or something. I don't know. Anyways. Um, but yeah, you have the function name, you have the non-existent parameters, you have the return type, and the function body, which inputs two numbers and repeats and then prints out the larger number. Okay. So yeah. Well, now let's get into talking about how to define functions that aren't main. So where we might do this and where you might expect it is on like completely outside of this main function. I don't believe C++ supports nested functions, although I think this might be the case for some, maybe especially older languages, but okay, that's not the point here. So if we want to make a max function, what would our return type be if we're taking in two ints? Oh, thank you. Thank you, Replit. But also thank you, Elaine. Okay, int. What should our what should our I guess function be called? I guess it doesn't really matter, but if we're gonna be okay. Well, if we're simple, we can just call it max. If you if you have some more like complex function that does more things, you should be descriptive. So it's like if you're reading through the code, you should be able to tell by the name of the function what it does. Unless it does like 50 things, in which case you should probably like split the 50 things into ones. So it shouldn't be like find the max value and print it out and I don't know, cook eggs or something. It should be clear and concise. Okay, how should we handle the parameters? I'm just gonna quickly set up the parentheses. Okay, yeah, I don't think you probably actually know this, but how I set up the parameters is we will just basically have a list of variable definitions without any like technically it's possible to initialize them, but I think that's going to be outside of the scope of this course. Okay, let's just initialize a variable called A and a variable called B. Oh, tab is how you complete it, right? Okay. And then functions need to have curly braces surrounding them. And this basically will delineate the function body. And now if we just paste all the code except for these variable declarations, because notice they've already been declared here, then yeah. Now we can have a maximal max function, and I guess if we're gonna be good coders, I don't know. I always like to end al. I don't know if my brother did this. Oh, shut up. And then you can just see out max a b. Actually, no, this is not true. You should not do this. Or I guess you could. Actually, wait. We should do this. Okay, does someone see anything wrong with this? There are actually two things that are wrong. One thing is definitely wrong, and one thing is it's wrong because we said so. A function is an equation. Thank you for that is not intended to be an error. Nice catch. Does anyone else have ideas? If you hit something is wrong here. Nathan, do you have any idea what is wrong? Okay, someone's already gotten it, but I'll give other people a chance. C and AB. Well, that is also true, actually. I should not include this either. Nathan, do you have any ideas? Okay, I have a correct answer. And it's this. I guess, I guess I could do this, but um, the key thing is that I haven't returned anything yet. And that if it's important, if you have If you have a function that has a return type that isn't void, you must return something. You can return multiple things, but you have to return at least something. And generally, you should try not to return multiple things because it does all sorts of weird things. If you if you say like, for example, I just return A, the function stops once it hits this return. So if I just say return A here, none of this would ever execute. This would all just be unseen. So I guess you could do this two ways. Now you can just say like, okay, then what should I replace this line with? Extra challenge. And I guess we can do greater equal and then remove this. What should I replace this line with? If we would just want to return the larger value immediately. And it looks really similar to this. All right, two correct answers already, but Helen, do you have any ideas? Three correct answers. Helen, are you here? Oh, yeah. Right. So we're going over functions. And I just want to see if you know what we should replace this line with, because we have to return something, and we should return the larger value here, which is A. So how should we return A? Well, if we want to just return A, then we kind of follow this structure and we can just say return the right variable, and boom, here it is. Right. For B, this is the same. So return B. Now, okay, one more thing I should talk about this. Okay, first of all, notice that one of these has to be true. We have to execute either return A or return B. This meaning this function will always return something. So there's never the problem where we forget to return something. That's the first thing. Second thing, notice that, okay, normally we put like an integer, a variable that corresponds to an integer here. Okay, question. Is print in Python the same as print in C++? No, Python, it's much more simpler. You can just do print whatever the heck you want to print. And then I think it might even be kind of lenient on like printing integers versus printing. No. Oh, that's not true. C++ is the same. But yeah. The Python, you just call it a print function. In cout, it's a lot more like nuanced. You have to do like couts and then this to kind of like break up what you want to see out, and then like between between strings, between literal strings, which like you control what it says, and between like variables. And then also there's like endl and a bunch of stuff. I'm not sure. Oh yeah. Oh no, whatever. But yeah. C++ is a lot more work, but it does things faster, so that's why C++ is better. Trust. Anyways. Yeah. But you'll notice that we're using this function kind of as a variable, and that's kind of the magic of like what this return actually does. When we return this, let's analyze what's happening in the code for a second. Yada, yada, yada. You declare variables, you print out, you input values, you print out the larger number is, and then you go here. So the compiler, when it sees this, it will instantly say, okay, this is a function. And so it will say, where the heck did I find this function? Go do 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 do, and it will reach this function here. And it says, okay, I found a function. I'm going to first create a variable a and b. I have input parameters, which means I will use this a and redirect it here. You have use this b and redirect it here, and then we'll like it'll execute the rest of it. Then we'll execute the rest of this function. First line, if a greater than or equal to b, or whatever. Okay, just whatever this turns out to be, it will return a value, and then okay, it will say it'll go back to where it last finished in the main body. It'll go here, and it says okay. Now let's replace whatever the hell was here with b. So this value now equals b. So you can use this as a variable, whatever. You can basically use this as an integer. So like, for example, if I wanted to say, okay, int c equals max ab and then see out c, that's possible. You can say, you're going to be really funny, you can do max a b, like c or something. Yeah, you can even yeah, because you can treat this max function as an integer, right? So you can actually pass it into another call of max and whatever. C++ already has a max function built in. Okay, yeah, no, that's kind of jumping ahead, but this applies for all functions, and C++ does not implement all possible functions known to man, so still useful. Max is just very simple to do. Yeah. But actually, what Elaine said, well, I think will tie into something that I'll talk about in just a bit. But yeah, I think I've covered most of that. Let's go back to the slides. Do. Code redundancy. Okay, structure, return type, function name, parameters, code. You've already kind of seen this in action with Max. Like, and then yeah, this is basically just the Max function that we did. I guess if we want to try it out, I guess we could go for a run. Two people give me their favorite numbers very quickly. If not, I'm gonna choose 42. Someone else. Favorite number 1 says Shaha. Oh, oops, forgot space. But yeah, 42 bigger. This is how you okay, yeah. Functions in practice. Right. This is a simple example. Yeah, I think you've already seen this. This is called the function call because I guess you're calling the function. The rest of this you've already seen. I've kind of gone through already. This is a very complex, very, very, very complex function, but this just shows what it can do. Basically, this is an algorithm to multiply a bunch of numbers very quickly with a bunch of like complex math and stuff. But like, okay, the gist of how it works is this. If you have like question, I have no idea what this means, Helen. Oh, sure, I guess. All right. Okay. Anyways, so yeah, basically this function works like this. Okay. Let's say you have two arrays, 1, 2, 3, 4, 5, 6. Wait a minute, this is FFT. Oh my God, this is not FFT. This is something different. Never mind. Okay. This is way too hard. This is harder to explain because this is actually the function I thought it was. But yeah. But okay, this basically has an array 1, 2, 3, and then it turns into a bunch of random wacky numbers that I have no idea what it would actually be right now because this is very complicated. But um instead of let's say I had like 2 arrays or 3 arrays to do this from. Do I really want to write all of this code and again? Like, sure, I guess I could copy Control C, Control V it, but that's going to just be a bunch of clutter on my code file, and I really don't want to have to scroll past that every time I'm like going past it. So instead, I can just call FFT to, I guess, this, I know what this means. So let's say this is an array that's the size of the array. You can have, I guess, the array. And then I'm just gonna move some stuff around. And then you can say like true or something. And then ta-da, it will change this for you. It will return a vector of this thing called a complex double, which is no. So yeah, just a lot of work in simplifying your code. Right. Probably not going to be writing something as complex as this for now, but whatever. Okay. This, I am wondering if we have enough time for it. We might not, and this does not instinctively look. Actually, no, this is fine. Okay, let's spend like 5 minutes working on this. Please give answers as soon as like you get them or something, I guess. Oh my, someone's gone really fast, and I think their answers are right. Elaine, have you done coding before? Figured. Let's wait a while for everyone else to. Speaking of getting water, I'll go get some water. Water.
Water bottle.
True. Okay, no, probably private message be that or something, but okay, yeah, I'll just delete it. One more minute. Okay. Right. The first one we have IDK of 2 and 3, so that goes here. 2 is not greater than 3, so it will move here and return 3 over 2. And the answer to that is, oh, here are the answers, by the way, is 1, because we have 2 integers and we're just going to do integer division. So we truncate everything after the decimal points, and 3 over 2 is 1.5, which gets truncated to 1. All right. Second, we have 1.4 and 6.3, but now they're passed in as doubles, so be careful. A and B are now doubles. We know 6.3 is greater than 1.4. So we do 6.3 over 1.4. Mental math says that is equal to 9 over 2, which is 4.5, and that is correct. Now, this is actually mostly also an exercise in like casting, just to make sure you remembered how to do casting and like how to go switch between ints and doubles. I hope you've learned that before. Between 5 and 3, you pass them originally as ints, but this double cast, just as a reminder for if you don't know or if my brother didn't tell you yet, this double cast basically says, hey, I promise with my life that this A can be interpreted as a double. And the compiler says, okay. A is a double, and then so it becomes a double. Same thing happens for B. Now we have a double divided by a double, and we will get a double result. Now 5/3 is 1.6 repeated, and so eventually somewhere it will throw in the towel and just ran it up to a 7. So yeah. All right, good job for everyone who got it. I think, yeah, okay. Functions can call functions. Like I kind of demonstrated this already, but yeah, it might seem a bit funky at first, but really this is just treating this as like a variable or as a value, which really is I think becomes intuitive. Overloading is a bit of a complicated concept, but basically if you, for whatever reason, wanted to like have the same function header. Oh, by the way, I should say a function header it consists of like the name and the name, the number of parameters. Yes, the name, the number of parameters, I think, and the re no. The return type doesn't matter. Just wait, then yeah, I think it's wait, I've forgotten. I think yeah. The name and the parameters, then the parameter types. Is it the parameter type? I think it is the parameter types. Yeah. The return type doesn't actually matter because that doesn't matter. Yeah. So like for the example, this would not overload because this has 3 parameters and this just has 2. But like if these were all called IDK, then we'd have some weird stuff happening. In fact, I don't even think this compiles because it's confused between these two. You'd have no idea which one to call once you see IDK AB because it doesn't really matter what this return type is. So yeah. Oopsies. Yeah. But like if you I don't really think there's a reason why you'd want to ever like overload if you're like following like just the best. I don't know. I sound like my CS teacher that always gets memed on right now, but if you like just you don't really need to ever use overloading. You can just like switch up the names a bit to make it more specific or whatever. Yeah. All right. Built-in functions. Okay, this is what Elaine was talking about. I will go over here and do some funny thing that you will not expect. I'll comment all of this out and you will see that it still runs correctly. Let's go with 42 and 1 again, and then yeah, same thing happened. So why is this? This is commented, by the way, so this doesn't actually execute. Turns out C++ has already implemented a max function for you because they are nice and they want you to have some fun. It's like, so like max they've already done for you, which means you can just call max randomly. Um, I think I don't actually know where this max comes. I think this max might come from another input file. It's definitely not IOStream. Or I don't even let me do a bit of investigative digging. Oh yeah, it comes from STD. But STD has already implemented this, so yeah, you will be able to write a max function by yourself. That means the max function that we wrote just completely overwrote what was inside here because we have greater priority in case we want to use like our own function with the same name or whatever. Yeah. Okay. This should conclude it for functions. Yeah, we have max. Another one you might want to use is rand. Rand outputs this rand differs between languages. In C++, it just outputs a value between 0 and a predefined concept called rand max. You can like just search up what it is for your specific C++ version, and then it'll tell you. And now, okay. Now let's move on to structs, which are more known as classes in the language. And actually, there are classes in C++, and actually, classes structs are a type of class, but structs are easier to conceptualize, even though you probably haven't heard of them before. So basically, what is struct? Okay, let's say you wanted to define a new variable type. You wanted to have store like some sort of information, like perhaps you wanted a student, and then you wanted to know, for example, like their name, their height, their grade, and you wanted it all to be in this one tight, snuggly place. Oh, what's the other thing I wanted to know about them again? The name, their height, their class, grade, yeah. Sorry. Okay. Structs basically will allow you to do them. And basically it will say, okay, each student will be given an integer name, string name, an integer height, and an integer grade. And then, yeah, that's the most basic way to apply a struct. You can also define specific functions within structs that will do some fancy things that we can get into a bit later with examples. So generally, yeah, that's how a struct will operate. Here, next. So yeah, um, let's say there is a struct called father, and we have a bunch of variables about him. We know his name, we want his age, we want the number of children he has, and not his occupation. We want to know whether he's left. And basically, we can define a function, a void function. Notice it doesn't have a return type. Leave with no parameters and just sets has left to true. By the way, I think these will all initialize to their default values, like empty string and 0 for ints is false for this. So that's why I guess, or you could also like just manually initialize them. There are these things called constructors, which I don't feel like I really want to get to, and because I guess you can just do this. Yeah, I think I'm just gonna teach structs classes and like private and like private, public. I think that might be a bit too much. Basically, we can, and so basically the way to go from a struct to its member like variable or member function is to just use a dot. So this will say we have a father, it's Bob. Okay, now we go to Bob dot name, so we know this is a father, and we'll go to the name of the father, and then this is our variable, and then we can just take it into be initialized or something. So yeah, showing you how it works. This is a very funny struct. Actually, it's not even I don't know, it is a struct, but like it's complicated. Yeah, don't worry about this. This is scary. This you will see if you pursue higher levels of competitive programming. Okay. There are also some built-in structs which can be used with include. The most useful of this, I believe, is pair, which is included in this utility file. Basically, what this does is very simple. If you want two numbers to be stored together, you got it. If you want to know, like, for example, you have some like main score and then you have a tiebreaker score, you can sort like an array of pairs just so you can have like a sorted array with some tie-breaking quantity, and then that's possible. The pair, yeah, the pair just has two member variables, first and second, and that's it. There's nothing else you can do with the pair. It's not very complicated, but I think that's part of why it's useful. Okay. Um, okay, I guess this is kind of useful. This is not related to structs. But yeah, you can use include bits slash std++h. This will just include everything. It'll make your file a bit slower, but it doesn't really matter. Okay, never mind. Yeah, this is just a bunch of tips. Yeah. Yeah, we can get to this once we do our struct example. I guess we kind of already did an example. Let's see, what can we do? Hmm. Okay, let's have you all write your own structs. So I already said we should have a struct. So just make a struct student which has information on name, grade, level, and name. No, there is a name. What else is there to know about a student? Grade level and height, sure. In double, actually. So yeah, I'll just give everyone a few minutes to give me like a kind of structure, I guess. Yeah. Message. What's the difference between a struct and a class? Okay. We have a bit of time, so I think it's possible that we can talk about it. Basically, in a class. Oh, important thing. At the end of struct and classes, you must have a semicolon too. I forgot to mention that. Yeah. There's you can okay. In a struct and class, you can have publics and you can have privates. But the public works like a variable that you would see in a struct. You can access this from anywhere. You can change its value. You can modify it. Yeah, yeah, yeah. Private is different. Private, you can only modify within your own class. So if I have, I don't even, so this will compile because this is private, but you can see it within its own class. However, the instant you try to change this value outside of the class, bang, doesn't know what it is. Or yes, it wouldn't know anything because doesn't apply for a duck. But yeah, you can't like you also can't say dot duck2. This doesn't look. When we have a when we just say dot equals 5, we're fine because this is public. Then so we try to modify duck2, but it doesn't know what it is. So instead we have to use good duck to modify the value of duck2. Right. Oh, and this is also private. We should publicize this. In ABCS, they will introduce like getters and setters because they're like paranoid that you're paranoid about, I think, like random people messing up the values within your classes. And so they tell you to keep all of your member variables private. I've never had to care about it. I don't think, I don't know. I can't speak to industry, but I've never had to care about it. But it's still good to know. Anyways, how would we create the student struct? Let me just go back. I'll give everyone maybe another minute or two. Never mind. I'm not going to show that. That's not a good idea. Funny. Elaine, that's funny. Okay, that's fine. So first, I have to start with the keyword struct. Pretty obvious. And then we name it student because, yeah. Normally, when you know what? Never mind. Okay. We want to know it's their name. So let's have a string with their name defined. Okay. Okay. We're cooking. We're cooking. We want a grade level, so we can just say int grade level. Okay. We're cooking. We're cooking. We're cooking. And we want a double to say their height. Then, yeah, just this. And don't forget our cheeky little semicolon at the end. That will mess you up, maybe. But yeah, that's just how to define a struct. If we want to initialize them, I'm just going to copy Elaine's code because I am too lazy to type it all out. Okay, I guess you should specify what, whatever. You can just use this to pass a string into it. So you can pass 10 into grade level. You can pass this double here. Yeah. Anything else? No, not really. Yeah. So basically, yeah, that's how to use a struct. Right. Now let's talk about some fun stuff. I said I was going to talk about the main function initially, but yeah. I'm going to do something blasphemous and return and remove this return 0. Now, will this compile? Just an open question to anyone. And if you can explain the reason why it will or will not compile. Aiden, do you have any ideas? Wait, student is defined as a struct. Yeah. I removed a return 0. Let me see. Okay, we can erase the duck class, unfortunately, because there we go. Will this compile? Seemingly the answer should be no, right? Because we just removed the return from this function. We need a return. But looks like it compiled just fine. So why is that? That is because the main function is extremely quirky. You do not need to explicitly return 0. It will default return 0 for you. This is the only function that will ever do this in your life. Do not bank on this happening. This will not happen with other classes. Also, the main function is very picky about which parameters it can have. It can either have no parameters or it can have this very specific type of parameter. These very specific parameters. Like you cannot get a single character that deviates this. Okay. Why is this the case? This is very funny. Yeah, like I don't know. I don't even think I can call this. Can I call this capital RC? I guess I could. But yeah, you must. Okay, if it has parameters, there must be exactly two parameters, and they must be an integer and a char star. What is a star function? What is a star, you might ask? Well, I don't know what a char is, but what is a star? Basically, it's going to denote an array. It's way too complicated to explain right now, but yeah, this is a specific set of parameters it must have. This will allow you to take in command line arguments. So basically, this is not going to be useful for like running it on like some predefined IDE, but I just want everyone to know that in C++, if you're going to like just run this basically, run this like on your terminal or something, you would have a compiler that is normally G++, D++. So you first compile it like this. Thing is a binary file, and then you would do dash slash dot slash thing to run it. But you can also put some stuff behind. And then that will be command line arguments. And then so these will be passed into main in this array. You do not need to know this at all. This is kind of weird. Everything is defaulted as a string. Yeah, for your purposes, you'll mostly just be working with int main. But always keep it like this. You can also not have like void main or you can have long. I don't think you can have long main. You cannot have long main. Yeah. You can also not have double main or any whatever. Only int. Anyways, let's see. What else do I want to talk about? I guess we can go over some of these specials. This is ternary. This is a fancy if statement that you probably will never need to know. It just makes things a lot shorter. Oh yeah. Okay. I think that's it. Is there anything else I should talk about? Classes, functions. Okay. Here's a funny cliffhanger just to end off this class, all right? Um, okay. Let's say we want to take the max of two numbers. And okay. You can call other functions from within functions. That is something else that you can do. Maybe you want to be a troll and call max to a min function the max function if you are like super funny. So basically, okay, they just formatted for me, but whatever. You can also do stuff like this. You can return the value of that another function will return. But what if I accidentally call myself? Technically, that isn't allowed. Or technically that is allowed because you are returning a value. But it seems like you're just gonna start stuck in an endless loop, right? Well, yeah. But sometimes it is useful to call yourself, even though you might think it might never be useful to get stuck in an infinite loop. But this is a concept that is known as recursion, and we will actually have, I think, a separate day dedicated entirely to this concept of recursion. So, yeah, stay tuned, and I think, yeah, that's going to be it for class today. Thank you all for coming, and we will see you tomorrow at the same time. Goodbye, everyone. Thank you for coming.
Bye. Thank
Goodbye.